Hello everyone, welcome to Join to Learn channel. As I said in the previous video that we have covered the entire standard signals in time domain. Now let us see these standard signals in discrete time domain. We have covered the standard signals in continuous time domain so far. Now we are going to see in discrete time domain. Standard signals, what's the domain? Discrete time domain. Discrete time domain is also important. Okay, so now let us see. First function, what did we see in the continuous time domain? It was unit step function. So taking the same function, let me change the sketch. Yeah, unit step function or signal. See, the concept will be same, but only the difference will be here the time domain will be same. The time domain will be varying. How will we represent in discrete time domain? U of n is equals to 1 for n greater than or equals to 0, 0 for n less than 0. Let us compare these discrete time domain signals with continuous time domain signals parallelly, so that we will get a clarity. U of t is equals to, what was this? 1 for t greater than 0. It was not equals to, only greater than 0, and 0 for t less than 0, and it was 1 by 2 for t is equals to 0. But here in this case it is different. Here it is 1 for n greater than or equals to 0. Now let us draw this sequence. Signal or sequence. We will say sequence when it comes to discrete time domain. This is n and this is u of n. As you know, n values cannot be fractional values. They must be only integer values. That is why I am taking n values as 0, 1, 2, 3, 4 and so on. So what is the amplitude at 0? Greater than or equal to 0. So this is 1. Here it is 1. Again at 1 also it is 1. At 2 also it is 1. At 3 also it is 1. And so on. So this is our unit step signal in a discrete time domain. Now let us come to impulse signal. We had also seen impulse signal, right? That was our second signal. What would be impulse signal? Definition: del of n is equals to 1 for n equals to 0, and it is 0 elsewhere. What does elsewhere indicates here? Else n is equals to 0, that means n greater than 0 and n less than 0. Everywhere else except at origin, the value of this, the amplitude of this signal or sequence will be equals to 0. Whereas in time domain, how it was defined? Del of t is equals to infinity, right? Infinity for t equals to 0. It is 0 elsewhere. This was our time domain. Whereas in continuous time domain, we represented like this. This was 1 because of the area. As we had also seen, minus infinity to infinity, del of t into dt is equals to 1. That is why. Now let us see the representation of this impulse sequence in graphical form. This is, I am taking this instance as 0 or origin. What is this value? Amplitude value, it is 0. Elsewhere at 1, at 2, at 3, at minus 1, minus 2, minus 3, all these intervals, the amplitude is going to be 0, right? This is our impulse signal or impulse sequence. Since the operations on signals has not been covered, I cannot tell you one thing, but okay, if you people can understand, I will simply draw a conclusion here. See, I am drawing the graph of u of n minus u of n minus 1. So this u of n minus 1 will be covered in operations on signals. This is called as time scaling. This is known as time delayed signal. Why it is delayed we will see in detail. when it comes to our operations on signal. As of now, you just see, you just draw the graphs of these two. How it was 0, 1, 2, 3, 0, 1, 2, 3. Everywhere else, at all the places, the amplitude was 1. Minus u of n minus 1. I am saying u of n minus 1 indicates that n, the value of n, the value of this impulse unit step sequence will start from 1. It will not start from 0. Simple guys. See, u of n, what did you write? 1 for n greater than or equals to 0, 0 for n less than 0. What I am telling here, u of n minus 1, I am asking you to take. So nothing but the same sequence, you have to substitute n minus 1 in place of n. That's it. 1 for n minus 1 greater than or equals to 0, 0 for n minus 1 less than 0. Now, what will happen? N greater than or equals to 1, n less than 1. So the sequence will start from n greater than or equals to 1. That means from 1 it will start. 1, at 2 also it is 1, at 3 also it is 1, and so on. Now what I am asking you to do, I am asking you to subtract this sequence from this sequence from this sequence. So what will you get? Everything else will get cancelled, and only at 0 instance, as you can see here, at 0 the amplitude is also 0, whereas here at 0 the amplitude is 1. So 1 minus 0, what will happen? It will again become 1. So at n equals to 0, you are having 1. So what is this sequence? Just now we have seen that this is del of n. So the conclusion which you can draw is u of n minus 1 is equals to del of n. This is important. While we are solving problems, we will use this property. Now the third, what was the third sequence which we saw in the continuous time domain? One second. Ramp signal or sequence or function, whatever you call this. How it was represented? Let me change the sketch. R of n is equals to n for n greater than or equals to 0, and it is 0 for n less than 0. This was the definition of ramp signal, whereas in continuous domain, how it was there, r of t is equals to t for t greater than 0, 0 for t less than 0. So now if you draw this one, if you draw the sequence of this ramp signal, how it will be? Only for positive values, this is having value n. So when I substitute n equals to 0, r of n is equals to 0. So at 0 it is 0. Whereas at 1, if I substitute n is equals to 1, r of 1 is equals to, see, r of n is equals to n, you have n is only positive. So what I am telling you is to substitute 1 in place of n. R of 1 is equals to 1. So at 1 the amplitude will be 1. At 2 the amplitude will be 2. At 3 the amplitude will be 3. At 4 the amplitude will be 4. Like this it will continue. This is n, this is r of n. This is the graphical representation of ramp sequence. Whereas in continuous time domain, how it was there, it was like this. It was existing for each and every value of time, whereas here it is existing only at integer values of time. So this is our ramp sequence. So what I will do is, here also we can draw one conclusion. Let us subtract r of n minus r of n minus 1. Okay. So just now you have seen how to draw u of n minus 1. In the same way you will also be drawing r of n minus 1. Okay. This is r of n. 0, 1, 2, 3, minus, and so on, r of n minus 1. So r of n minus 1 is equals to, it will be, one second guys, n minus 1 for n minus 1 greater than 0 and equals to 0, 0 for n minus 1 less than 0, right? that implies n minus 1 for n greater than or equals to 1. So if I substitute 1, what will be my value? It will be 0, right? 1 minus 1, 0. At 1 it is 0. At 2 it will be 1. Again at this is at 1, amplitude is 0. At 2 it is amplitude is 1. At 3 amplitude is 2, and so on. So now if I subtract these two at 1 second, yeah, at 1 what do we have? We have here the amplitude is 1, right? 1 minus 0, you will get 1. Okay, from 1 it is starting. At 0, 0 minus 0, 0. At 0 it will be 0 itself. At 2 the amplitude is 2, and here the amplitude is 1. Again it will become 1. At 3 here the amplitude is 3, here the amplitude is 2. Again it will become 1. So here at every instant of time the amplitude will be 1. So but it at 0 it is not having any amplitude, it is having 0 amplitude. So what is this? This is u of n minus 1, right? At 1 it is getting started. Now what I can say is r of n minus r of n minus 1 is equals to u of n minus 1. What I will do is I will substitute n as n plus 1. Now what will we get? R of n plus 1 minus r of n plus 1. In the place of n I am substituting n plus 1 minus 1 is equals to u of n plus 1 minus 1. So what is this? R of n plus 1 minus r of n is equals to u of n. So this is also one of the important conclusions. What is that? Let me write it here itself. What is this? Consider this as first conclusion. The second conclusion is r of n plus 1 minus r of n is equals to u of n. These two are the conclusions in discrete time sequences. You can also consider this as one of the conclusions, but this is not much useful while solving the problems, but this conclusion will be very much useful. So this is about discrete sequences or signals. Next we have operations on signals that we will be discussing in a separate video. Yeah, if you have any doubts regarding this topic, you can ask me in the comment section. And one more thing which I would like to say is, yeah, I hope you guys are preparing notes in a very neat way. This will be very much useful for you in your exams. Okay, and yeah, that's it guys. We are only left with 3 more topics which will be covered in 4 to 5 videos, I guess. So most probably we'll be completing that in the next week. Okay. Okay guys, thank you for watching. We'll catch you up in the next video.